Yes, ma'am, I can see it now.
Okay. So let's do subgroup. A non-empty set H is called subgroup if it is subset of G of group G under binary operation.
Okay, ma'am.
Under binary operation. And I taught you binary operations, right?
Yes, ma'am.
Subgroup H is also group itself. Why it is? I'm telling you.
Okay,
Uh,
ma'am.
Means whenever we use this word sub of any, it means a part of that thing. Means this is a part of group, which is subgroup.
Okay.
And here we have in definition it is subset, means a part of that group G. So if in daily life we can understand as if we have a bag of wheat,
Yes, ma'am.
okay, if we take some part out of them, then it has the same properties like this, right? So you can
Yes, ma'am.
understand as this is the group and this is subgroup, means a part of that. Okay.
Okay,
So
yes, ma'am.
whenever we use sub word, sub means a part of the same thing. Okay.
Okay,
So
ma'am.
it has same properties as whole. Okay. That is
Okay.
why subgroup H is also group itself.
Okay.
Means it has the same properties of group.
Okay,
Got it?
ma'am.
It can be written as this H is also a group in itself. So we can write this group also. And but in G, this is subgroup, means a part of this group.
Okay, ma'am.
Means this H having few or all elements of G. Can
Okay.
have few elements of G or can have all. And we can say this is also subset, means a part of G. This
Okay.
is also group because H also have the properties of same as G. That is why we are writing here both are group. Got it?
Okay, ma'am.
This is whole one and this is a part. Got it?
Okay. Yes, ma'am.
So now let us understand some important properties or points about subgroup. So we are going to learn them. Important points about subgroup.
Okay, ma'am.
And we'll do this weekend also, okay? And we'll do some extra on this
Yes, ma'am.
weekend. And this weekend on as well as on next weekends also, because we have missed lots of units,
Yes, ma'am.
right? Yeah. So means I'm thinking that we need to do all weekends of this month so that we can cover.
Yes, ma'am. That is fine.
Okay, all right. So let us understand first point. A subgroup H of a group G is a subset of G if H is itself group under same operation, under the operation in G. It means we have done already this property, because we are saying here a subgroup H of a group G is subset of G, and
Yes, ma'am.
if it is an H is itself group under the operation in G, which is the same operation of G. This is also got it in, got
Yes,
this
ma'am.
point? Okay. So now let us understand the next point. A subgroup of a group consisting of only the identity element. It means as that this only this identity element, either under addition means it has only 0, and under multiplication it has only 1, then
Okay,
this
ma'am.
is called, then it is called the tribal subgroup. Tribal subgroup.
Okay, ma'am.
Okay, if it is, it has only identity element, because if G has like elements A, B, C, and E, and this is identity.
Okay.
Then if H is equal to E, then this is called trivial subgroup. Okay.
Okay, ma'am.
And now let us learn the next point. A subgroup H of a group G a proper subset of G is that H not equal to G. It means when we find a subset like H is subset of G and
Okay,
H
ma'am.
not equal to Z, it means H has only few elements, not all elements. Okay. So in this
Okay.
case, we say this is proper subset. This is proper
Okay.
subset. Yeah. And H only subset of G. Then H is called proper subgroup of group G.
Okay, ma'am.
And here H is less than G. Means having less elements, not all. Okay.
Okay,
Only
ma'am.
few elements in H. And now the next topic. One second. Just- Okay, so let us do some examples in the syllabus also. Z, Q, R,
Okay,
and
ma'am.
C. We need to show them under addition. Okay.
Okay. Ma'am, are you sharing your screen?
Not now. I'm sharing you.
Okay.
Wait. Wait a while. I'm telling you about one. How can you show that? Okay. And the same way we can show any of them. Okay.
Okay, ma'am.
Like questions. Um, now in your syllabus, and these are also examples of group.
Okay,
This
ma'am.
is a first point. See in unit one. or part A, we have these examples Z, Q, R, C under addition. Then Q, by subtracting this 0, and then we'll show under multiplication. Then
Okay,
we'll do
ma'am.
the Z and the set of residue class. We'll do later this. So first of all, let us show under addition.
Okay, ma'am.
So first, Z, Q, R, and C are examples of abelian groups under addition. And you can show them by taking means absolute value, like having some numeric value, or you can
Yes, ma'am.
do them by using variables also, like,
Okay.
and let's just take Z. And first, let let us show Z is a group under addition.
Okay, ma'am.
Addition, and we can take by using like so. mm Here, z, a set of integer. So we have here set of integer. We can take in this way, uh, dash dash dash, or you can take here minus infinity also, or you can take like dash 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 minus minus 2 minus 1 0 1 2 up to so on. We can take in this way. It's a set of integers. Got it? So
Okay,
now
ma'am.
first, z z is said to be the group under addition
Okay, ma'am.
if it is satisfied the following axiom. The following axiom. So first axiom is
Yes, ma'am.
closure axiom. In closure axiom, we have uh, take any two elements. Okay, take any positive, negative, any one. So let's take 2 comma 3, or you can take any, not only it's 2 comma 3, and these both belongs to Z, and
Okay.
also 2 plus 3 belongs to Z, or you can take another also if you want, like 1 comma minus 1 also belongs to Z, then minus 1 plus 1, which is 0, belongs to Z. Got it? Then we can say closure axiom is satisfied. Then we can
Okay.
say closure axiom is satisfied.
Yes, ma'am.
We can do about, you can write not mandatory to write this line. I'm using to understand when you will see the letter.
Okay, ma'am. Yes,
So we
ma'am.
can do about for any elements of Z.
Okay.
Hence, closer axiom is satisfied. Is satisfied.
Yes, ma'am.
Now let us do next associative axiom. So in associative axiom, we need to take three elements. So let you can take any like 2, 3, 5 belongs to Z, which are integers. Then do 2 plus 3 plus 5 is equal to 2 plus 3 plus 5. We have the same result on both sides, right?
Yes, ma'am.
10 is equal to 10 on both sides. So we can say that associative, you can write that the same line, this we can do for all.
Okay.
Okay, you can write this, you can do for all any elements of like you can write this
Yes,
the
ma'am.
same line here also. And we can say hence associative axiom is satisfied.
Okay, ma'am.
Now let us do for next existence of identity.
Okay, ma'am.
Next, existence of identity of identity.
Yes, ma'am.
Mean let or any element, you can choose any, or you can show by using variables also. Okay, as we
Okay,
have
ma'am.
done before. Here you can to take 2 belongs to Z, which is an
Yes, ma'am.
integer, and here 0 also belongs to Z, and 2 plus 0 is equal to 0 plus 2 gives 2. And since 0 is the additive identity,
Yes, ma'am.
so we can say existence of identity, this axiom is satisfied because we have 0 in our set. That is why.
Okay.
Okay.
Yes, ma'am.
So now next, fourth, existence of inverse. So in set Z, if 2 belongs to Z, then minus 2 also belongs to Z. If you can take any element like 1 belongs to Z, then minus 1 also belongs to Z.
Yes, ma'am.
If, if 5 belongs to Z, then minus 5 also belongs to Z. And if 2 plus minus 2 is equal to minus 2 plus 2 gives 0.
Okay, ma'am.
So minus 2 is additive inverse of 2. Minus 3 is additive inverse of 3.
Yes, ma'am.
Or we can say, or in set Z, there is an element along with its additive inverse.
Okay, ma'am.
Means if we have 2, then must have minus 2. If we have 3, then must have minus 3. It means for each element we have its additive inverse also
Okay.
in set of integer.
Okay, ma'am.
Hence, existence of inverse axiom is satisfied.
Okay, ma'am.
And now let us do the next axiom, commutative.
Yes, ma'am.
Fifth one, axiom since you can take any elements, means two elements,
Yes, ma'am.
2 comma 5 belongs to Z, then 2 plus 5 is equal to 5 plus 2. Means we have the same result if order is changed. Okay.
Okay.
So we can say commutative axiom is satisfied. Okay. Since Z satisfied all these five properties, then we can say Z is an abelian group. Got it?
Okay, ma'am.
Since Z is satisfied,
Okay.
closure, or you can say all five axioms, all five axioms.
Yes, ma'am.
Hence, Z is an abelian group. Okay.
Okay, ma'am.
In this way, you can prove for Q, it means a rational number, for complex number. Okay.
Yes, ma'am.
Uh, yeah. So now let us check in the next topic. Um, okay. Next, let us understand the modulo. Okay. Modulo
Yes, ma'am.
n, uh, residue classes modulo n under addition.
Okay, ma'am.
Wait, give me a few seconds. Give me a few seconds. We are doing it. Okay.
Yes, ma'am.
So now let us understand. First, we learn the meaning of modulo.
Okay, ma'am.
Modulo incongruent modulo.
Okay, ma'am.
So if we have A and write in this way mod n, it means
Yes, ma'am.
so A is dividend,
Okay.
B is remainder,
Okay.
and n is divisor.
Okay, ma'am.
Okay, this means
Yes, ma'am.
n is divisor, B is remainder, and A is dividend. Like
Okay,
if
ma'am.
we write is 14 congruent uh, modulo means we write in short modulo 3 means when we divide 14 by 3. Okay, so
Yes.
like 14 by 3, so 3 for the 12 here we have 2 as a remainder. We don't write this
Okay.
number, we don't write this portion, we write only dividend, remainder, divisor. Got it?
Okay.
So this means congruent modulo.
Okay.
Got it? Okay.
Yes,
So
ma'am.
tomorrow we'll do in extra hours and we will
Okay,
finish
ma'am.
this. Okay, and
Ma'am,
time.
tomorrow what time?
Shall we do at 12?
Yes, ma'am. Okay.
Is it okay? We'll do at
Yes, ma'am.
12. Okay.
Okay, ma'am.
And maybe we'll do till 1:30 or 2 p.m.
Yes, ma'am. That is fine.
Okay. All right.
Thank you, ma'am.
Okay.